Hello Year 11, or possibly just Mabel. I am just going to go through part 5 of question 13 from the June 2006 additional maths paper, because that has been requested. I'm going to do it on a whiteboard. As you all know, I do not own a fancy calculator, and I've left the ones that the school has kindly provided me with at school. This is my mythical calculator I've told you about many times before, which I've owned since I was in Year 7. It does not have that SD button, which is super useful. The reason that that is notable for this question is there's a lot of surds going on, and my calculator doesn't do surds. You can also see there's actually a bit of it missing, so it's sometimes difficult to know what number that actually is, but I'm going to use that, or Excel, and I'm going to work through part 5 of question, I've already forgotten, 13. So this is the pyramid question, and it is the bit where you are finding the area of triangle VAB. So I'm going to sketch that out first of all. So this is the triangle that you're working with, and it wants you to find the area of this triangle, and then it says hence or otherwise find this distance, and we know that that is a perpendicular distance. Now, from the original question, we know that length A to B is 20 centimetres, and we also know that n is the midpoint, so it says that in the original question. So I'm just going to put those two lengths in there. You were also, in part 4 of the question, required to find the length Vn. So you should already have that length. To find that length, you can use Pythagoras. So you can do root 425 squared, so that's the hypotenuse, minus 10 squared should give you Vn squared. So you'll have 425 minus 100 equals 325. So Vn equals root 325. So we can also draw that onto the diagram like so. Now, to find the area of triangle VAB, we can just do base times height over 2. So area of VAB equals half base times height. So it is 10 root 325. I'm going to get rid of this bit and move this bit up here because we don't need this bit anymore. Okay, now as we just said, the area of a triangle is half base times height. So if I spin this around so that the base is this line, then the area of this triangle, same triangle, would be half base, which is now root 425, times perpendicular height, which is the distance we are trying to find. So the area should be root 425 times AM. So I'm going to write that down. The area of VAB should be AM times root 425. I'll just show you again why that is, because if we make root 425 the base, and then this is the perpendicular distance, then half base times height would give us the area. That's just reminded me that I would need to divide that by 2. But we already know that the area of VAB is 10 root 325. So we know that the length AM over 2 times root 425 is equal to 10 root 325, which means that AM must be equal to, multiply both sides by 2, so it's 20, root 325 over root 425. And it would be best to work out on your calculator what this is in surd form, but my old calculator tells me it's about 17.5. It does say hence or otherwise. There is another way of doing this. You could do it via similar triangles. The triangle AMB and the triangle VNB both share this angle. So if we draw AMB, then that has the angle theta here. And if we draw VNB, that has the angle theta here. If we flip this triangle around, then you can see that those two triangles are actually similar. And we know that VNB has these measurements. And we know that AMB, well, we know that A to B is 20. So as soon as we've got corresponding measurements, because both AMB and VNB have got a right angle and an angle of theta, so these two lengths must be in the same proportion to these two lengths. So you would also be able to work it out using proportion.